Hello folks, I think it's the Friday the 13th today, so unlucky for some. And it's been unlucky for this Planet 2000 radio with its damaged power socket, but we've got replacements in stock. These originals are some kind of Bakelite. That wants to stay in the off position. I like these sets very much. Some people hate them, and I find they've got exceedingly good receive clarity, transmit clarity, etc. But there you are. We won't hear about bleed over boxes. We did that virtually current model TTI 550 the other day, and when Mr. Chippie was outside the property, and the driveway is 50 yards away, it overloaded such that we couldn't hear him at all. So of course it worked absolutely fine when it wasn't 50 yards away, but it just goes to show that, you know, if there aren't the all the users on that there used to be, you can't tell what's good and what's bad. But we do have instruments we can tell that on. I've not been well for the last few months, and I just haven't had the strength to be setting up the tests with 2 signal generators to prove bleed over. Hopefully we were getting in a land of being somewhat better. Right, let's put that's on the main meter. Put picture in picture on. Is it in the right position? No. I may as well take the lids off this first. So they're quite difficult to set up. And because they're quite difficult to set up, most of them aren't set up. So they were $89.99, and they were produced by a company called Mickey Industries. Because in this country we wouldn't have in England we wouldn't have, in the United Kingdom we wouldn't call a business Mickey Industries, or we'd be thinking of Mickey Mouse Industries. And this is one of the things with the Korean company LG. LG is Lucky Gold Star, and you wouldn't have a company with the word lucky in it in this country. But obviously you would in Korea. It's important there. So they went as Gold Star, and then they become LG, and then they've suddenly discovered that suddenly seem to have decided in their advertising that LG means life's good. No, it's Lucky Gold Star, folks. They just seem to be moving away from that. This was the thing with Nissan, wasn't it? How it's pronounced in the UK. And they produced their motor cars, and they were Datsun, because couldn't possibly think in the 1960s that we could have Japanese things. So got to make it sound different, and then of course in 1983/4 it went from Datsun to Nissan. Right, so on to this. It should be a standard, if we can call Cybernet standard. Seeing as Cybernet's long gone, I'll go and get a standard Cybernet mic. Relay operated radio, don't have any trouble with the relays, and we're still having brand new sets with relays in them. I thought it was old hat in 1981. I still think it's old hat. We'll deal with that when we fix the set. Customer says, I've had a quick look at this broken power socket. My hobby SWR meter reads 2 watts. Needle doesn't move on TX or RX. However, it seems okay on TX and RX, he says. So switch the power supply on. We'll see. They never do 4 watts, but it doesn't matter anyway. But we want them to. What really want it to do, certainly into the 3 point something, don't we? I mean, a lot of the new sets do not go beyond 3.4, even with adjustment, and some won't go beyond 2.7, and a lot of them come out of the box around that 2.7. But again, we've done the tests time and time again. It works on decibels. You know, 4 watts isn't double the range of 2 watts at all. You know, difference between 3 watts and 4 watts is probably 100 yards. Right, so we're going to transmit, and on our rather selective test set it's 2.6 watts on, you've got it on 19, why would anyone want it on 19? We've got it on 2.6, yeah. And 2.6 on channel 1, and channel 40 2.8. So that doesn't sound like it's tuned right. Back to channel 20, we're drawing 1.225 amps. Now that's a lot of current for the output we're getting for a radio this age. If it was a modern CPU controlled radio which took half a second going to transmit, we'd expect that kind of lower power and higher power consumption. So we want to switch to Roger Bleep off because I can hear it, and is low power on the back? It is. Low power is 100 to 110 milliwatts. We'll do a quick deviation check for what it's worth on this test set. Wow, it's 1.5 on this test set. We don't do the VCO unless there is need to do that. I have done a demonstration. We had to work it out. It's a FAF, but it's very stable on these sets. Let's go back to full power. That's full power. So as he says, the meters, I mean, what do I do if the meter's not working, you know? You know, it's not like we've got scrap ones of these. By the time we buy scrap sets, this is how we buy scrap sets. A bit of a chassis, it's got some parts on it. Somebody's had what they think are the best parts, but that's how I buy the chassis. Here's a more complete one. You know, but people have had the meters and things like that. We get the odd AM sets donated. That's got a meter, but it's not compatible with this, so, you know, there we are. $27,79125. Yeah, you see people on eBay, don't you, with a bucket load of meters for £35, and they get it, and so they just nick them off things. But then who's to say those work? Right, we'll just see where we are on frequency, but it's going to be, the test set's only been on 10 minutes, so it's going to be a bit low. 27,790.7. Now, I'll tell you what, we'll pull that up right now. Now I can always drop it back down. So the reference crystal is there. I think we'll have it. I'll have it 4 toggling 5, and then as the thing warms up I can adjust it down. But right now we'll put the signal generator 27,79125, just so it's exactly right. Just make sure these controls are in the right position. So squelch down, tone. We want tone probably about there because it does affect the SINAD. And we'll plug the extension speaker in, otherwise we won't be hearing anything. And by extension speaker, that means into the test equipment. Public address into that one. Let's do PA first. Testing 1 2, testing 1 2 1 2. Got a dirty volume control. those sealed ones, but we can usually get some cleaner into those. So, right, out of PA, back to CB. $100 microvolts on the signal generator. And is the meter reading? No, it's not. And on transmit, it's not. Not ideal, is it? Right, let's have a look at where we are with the SINAD. To be honest, that's not too scary. 1 microvolt. I think it's supposed to be better than 1 microvolt. Well, it is 1 microvolt. It doesn't sound right. For 10 dB, it's still 1 microvolt. And for 20 dB, it will at least it'll do it. It's 2.7. Squelch is always good on these. Squelch to full. It's a bit tough, but it's 3 millivolts. I think we'll put 3000 microvolts. Just so people understand better. Turn the squelch down. See where the threshold is. Set threshold on the radio. Dirty squelch control. I can't get a reading because of the control being dirty. Switches are alright. Sockets are alright. Okay. Oh, frequency was at 2779074. And at the moment it's 2779125, where it should be. So see if we can do something with the transmitter. First of all, I'll print myself off my information. Okay, what I've done is to print out 2 pages of the instruction book. I've got the whole thing on file, and that's got the specification. It allegedly does 4 watts, but they never do. But it is 0.5 of a microvolt it's supposed to do for 10 decibel SINAD, so better than 0.5. So there we go. Two and a half amps on transmit, but I've never seen one that bad. We've got the redrawn circuit here. I've printed it A3 so I can actually read it. And they've got the layout as well. So we'll start with the transmitter. Go through this. So phase lock loop here, and we're going to have L1. That's going to be VCO, so I'm not going to touch that. So L2, L3, 4, 5 and so on. Chances are we don't want to be touching L8. Right, so we start with L2. Right, here it goes. Going to transmit. I've put my dinner in the oven. We're on channel 20. That's helping. That's definitely the optimum. Five. Of course, we've got paint on that, haven't we? Just to make it. Oh, I don't want to break that, do I? I don't know what we're going to do here. Try and chip it out with this screwdriver. See if I can move it with the screwdriver. Obviously I can't adjust it with the screwdriver. I can see before the day's out this is going to get broken. And I'm going to have to get one off a scrap chassis. See, it's filled the slot up with paint, and so because you can't get a tool in to do anything, let alone the sealant. What's L11 do? Oh, it's received. Fine. Right, back to transmit. It's over 3 now. See if we can take this out. And you know what's coming, don't you? Put it in the other way round so we can actually get into the slot properly. 3.2. Well, there's one thing, it's not being messed with, has it? Right, I think that's going to be it, 3.2. Out of interest, to see what power it does at 14.4 volts, which our Nissan Leaf charges at. And other modern cars do. Which button do we press here? Still 3.2. Back to 13.8. Right, well that's that done. See what receive's doing. So put the oscilloscope on. Don't have a normal detector arrangement as such. It's going to be L17. Which is that one there. So 100 microvolts on the signal generator. Let's put that up on the oscilloscope. Enough volume for it to be... Oh dear, oh dear, oh dear. Is that because we're only going in with one wire? Yeah. Right. Let's reset the detector. To be honest, I'm going to do the IF first because it sounds IF off frequency. Fourteen, 15, 16. 14, 15, 16. That's the one. 16. And that one, whoa! Drop the attenuation. The amount of 10.24 going into the receiver is on this coil, and again miles out. So having done the IF, we can do the front end. See, that's about spot on. Drop the attenuator a bit. I'm not even showing you the right thing. L12. Spot on. So the front end were right, the IF was wrong. 13, what's that? I haven't touched it. Yeah, another IF. Let's put the signal generator up to about 12. That's going to be so much better. Right, so our new reading is 0.52 for 12 dB. For 10 dB, it's 0.46. For 20 dB, it's incredibly only 0.76. Right. So if we go back to what the manufacturer said, better than 0.5 for 10 dB, and we've got 0.46. So there we go. I'll go and have my lunch, and we'll come back to some of the we'll come back to the presets and see what's up with the meter. Before we go any further, we'll go on to the transmit deviation. Wallow. It's absolutely spot on, peaking at 2.5. So no adjustment needed at all. I'll just check with the Marconi test set. What's that reading? It's 25. It's reading low today, so I won't take any notice of that. Okay, so the next day I want to get this finished. We did the deviation. So the only thing to do to this is to find out why the meter's not working. So, if it is the meter that's not working, that's what we're going to check. It was Radio Club meeting this morning, so I was hosting that in my private chapel. So it's now afternoon and we'd like to get this put to bed. So let's see whether they're getting anything on this meter. I'll have to take the other lid off. It is immaculate though. So where's the meter wires go? Right, well, I think we can get a probe onto that. We've got a road trip tomorrow to near Barnsley. Bought a broken camcorder, which for some bizarre reason, this is Mr. Chippie spotted it on Facebook Marketplace. I don't do Facebook Marketplace. I don't do Facebook. I remember Mr. Chippie going to buy a pair of headphones, and this lad comes from between two council houses from an alleyway with these headphones. He obviously didn't live there, and you think, hang on a minute, I don't know where you live, and what happens if these are stolen? Not my way of dealing. Anyway, we're going to this bloke's house. I think he's a younger person. I think it's Mum's house. Okay, so let's see whether our test set's on frequency. Not quite. 79125. I'm going to put 100 millivolts on the test set. So I'll just turn the volume up. We can hear that working. Then let's put the probe on the meter. We're getting 1.49 volts. So I'll just put that back on. So with the other hand, I'm going to turn down the signal generator, or turn off the signal generator. Nothing. Signal generator back on. So it's the meter that's faulty. Did I switch that meter off? The clip went from somewhere. Right, well, how do we get the meter out? I expect we've got to take the front off, and I know that some of these things are captive on these sets, so it's not like you can, it's not normal. Mind you, nothing about these sets is normal, is it? So I think we've popped the front off to some extent, but the knobs and things don't come off. The more I see how shiny this set is, where has it been for 40 years to be in this kind of condition? It's great. Like it's been in somebody's living room cupboard, in its box, with an electric blanket. So hopefully we can kind of peel that back enough to get to the meter. I'll tell you what I'll do, I'll unsolder that meter. I haven't put the soldering iron on, so I've just switched that on now. I'll just see whether we can get any of these screws out from its support bracket. I never dreamt I'd ever be doing things like trying to repair people's meters. You know, it's a component. You don't. I remember somebody coming into my shop back in 1979 when we had the HMV dealership, and Mister, can you mend my torch? Says this kid about 8, you know. And what can you do? You fix the lad's torch for nothing, and just hope there'll be a customer in the future. I'm glad this isn't the yellow meter, because you know that would be very, very hard to swap. Can we get the lamp out of this, or is it all congealed? It is difficult when And that, well, that's the end of that meter lamp, isn't it? Because the wire snapped off. Right. So it's not like the needle's stuck. So we've got an open circuit coil. I'll bring the meter back. We'll put the meter on the meter. No, the coil's open circuit. So have we got anything that's going to fit? That's the opposite way on. That is the same meter, folks. That looks like a Mustang meter. Wow, what's the chances of that? And I wouldn't have saved it. I wouldn't have saved it if it didn't work, but yep, absolutely fine. Is it making any? In fact, it's red. Let's see if we get that onto the thing. You can see it swinging across with the ohm meter on it, so that's pretty nifty. Oh, I'm pleased about that. Does it work the same way round? No, it's the opposite way. It's the same meter, but it's the opposite way on. Oh, isn't that frustrating? Put that back. Are there any? What's this one? That's that type. See, that's what you'd get in a Maxon set. It's not the right shape. It's about the only meters we've got. Pause the video and I'll look amongst AM junk. You know what? This Mustang meter, it's low enough profile to fit in upside down. So that's what we're going to try and do. So taking the scale out, so taking the lid off it, so to speak. It's a matter of doing this without catching the needle. Putting the scale back from the other meter. And the good thing here is, with it being the same meter but upside down, everything should fit. The scale back in. So the bracket was in like that. Okay, so I'm back with you. Put that circuit diagram, I think, to one side. We need to just know the preset for power meter, which is the one at the back, and the one for the S meter, which is here at the front. I don't know if we did low power. So, where did I put the microphone? I've never been able to put a meter in upside down before. But the fact this is the right meter but the opposite way on is absolutely amazing when I've only got 3 different meters available. So there we are. It's got a new meter lamp in it, and it's the right meter but upside down, but you've got the latitude to mount it either way, which is I just find unbelievable. Never seen that before. Just shows I've never had to change one of these before. So should we do the S meter first? Yeah, I'll put S9 on the test set. There's S9, and lo and behold, it's virtually spot on S9. So just do a little tweak there, and that brings us spot on the S9. So that's that bit done. Look, I've got my wire around the meter lamp. It's even the right brightness, which is incredible. Right, so I'll do the transmit one, and it's the preset at the back. I'm not a lover of vertical presets, so it wants to be in the centre of the red zone, which it is. And let's do low power while we're at it. It's on the back, isn't it? Low power is 400 milliwatts. I must have set that. I've forgotten because it was yesterday. Yesterday, all our troubles seem so far away, says the song. We're done, aren't we? So 3.4 watts we ended up with. I've got to do that power connector. I hate adding things up like this, you know, because we go from quite a small amount to everything adding up. I remember doing a car radio for somebody when I was at Nottingham Radio, and it was a Ford car radio, and I spent hours and hours and hours dismantling this thing because the printed circuit board had got loads of earthing lugs because it was too cheapskate to have a double-sided printed circuit board. And I probably spent 3 hours on this car radio, and I thought I'll just charge him 20 quid. I could get a new one from a scrapyard for 8. Oh. So we've got a very broken socket there. We've got these in stock, and I'll go and get one. Right, so we have these in stock. I've got them on eBay. Imported. They're exactly the right one. Brilliant. Drops it on the floor. Now I better get it the right way round, hadn't we? So, looking at that, the indent, they've got positive to the bottom, and it says positive and negative on the radio. Make sure that the original connector fits, which of course it does. Very nice. Right, I'll wire that up. Okay, there we are, a nice new power connector. And I sprayed the volume control while the front panel was off, and the squelch control, and the RF gain works anyway, and the tone control. Time to put the lids on. So a lot to do, but I think worthwhile on a set like this. I'm not the only one who likes these, you know. I probably said before, somebody I was working with when I was at Groves Organ Builders, they were getting married, and they asked their brother if they could have a CB radio for their wedding present. And this person had been on my testing panel, so every week we'd swap the radios over for a different new set. And the one which I had difficulty getting back from them was the communicator in I440DX. And while I'm telling you this story, this is of course a Planet 2000. When we open it up, You'll notice it says on the printed circuit board UK 4000. So Serpent UK 4000 was clearly what it intended to be. And it was LCL doing the communicator, so it's LCL communicator and I440DX. Anyway, he said he wanted an LCL communicator and I440DX, and I got one for his brother from the wholesaler, and and that was fantastic. But out of all the sets he could have asked for, he wanted one of these. Out of all the sets he'd tested with us, which was something like 120, it was one of these. So, and I will say he lived in Nottingham, and there's a lot of usage. Anyway, it worked for them. So, just put some screws in for now. We'll get the aerial plugged in, test gear switched off. 3.4 watts. Let's get the aerial on. Enough screws to hold it together. Are we on low power? Yeah. 1 nano, Roger. 1 nano, Roger. Well, I could say it's tea time, so there we are. Nothing I can hear today, and it exceeds specification, which is great, but never expect 4 real watts out of these. You might get 4 hobby watts out of them, but not what we're reading. So I'll put some more screws in this. I dropped one of them on the floor, so putting that meter in was 45 minutes. But we only got 3 meters available, and I just think it's absolutely incredible that I was able to put that one in upside down. So there we are, and it's the right meter, but it was the opposite way on. Thanks for watching the Planet 2000 using the UK 4000 chassis from 1981.